without a successful and fully funded Artemis program, we risk losing the moon to China.
The world thought the space race ended decades ago, but it's back, this time with a new challenger.
Chinese space program's goal of placing astronauts on the moon by 2030 and eventually building a lunar base there.
While NASA rebuilds its footing, China is quietly planning a $66 trillion leap toward the moon. What they're building up there isn't just science, it's strategy, power, and the start of a new era for humanity. The new space race begins. In the 1960s, the world watched two giants fight for the stars. The United States and the Soviet Union turned space into the ultimate battlefield, not for weapons, but for pride. When Neil Armstrong stepped onto the moon in 1969, the Cold War suddenly had a winner. America had proven it could do the impossible, but that was over half a century ago, and history is beginning to repeat itself, because now a new challenger has entered the race. China. And this time, the finish line isn't just about getting there first, it's about staying there forever. Over the last decade, China has gone from a cautious spacefaring nation to one of the boldest players in the cosmos. They've built their own space station, launched fleets of satellites, and landed on both sides of the moon, something no one else has ever done. And now Beijing has set its sights on the ultimate prize, a crewed landing on the moon by 2029. At first glance, that sounds ambitious. But what makes this timeline believable is that China rarely promises what it can't deliver. Their space program moves like a machine, quietly, steadily, and always forward. While NASA's Artemis program faces delays and funding fights, China's plans unfold with clockwork precision. Still, the question remains, why the moon? Why pour billions into a place humanity has already visited? Because the moon is far more than a barren rock. It's the most valuable piece of real estate in the solar system. Scientists and economists estimate that the lunar economy, built on mining, construction, and fuel production, could one day be worth over $60 trillion, maybe even $66 trillion if every resource is tapped. Beneath its dusty surface lies a treasure chest, helium-3, a rare isotope that could power future fusion reactors, precious metals like platinum and titanium, vital for electronics and spacecraft, and most importantly, water ice trapped in the moon's south pole, the key to life and fuel in space. If you can turn lunar ice into oxygen to breathe and hydrogen to burn, you don't just survive, you build. The moon could become the world's first space refueling station, launching missions deeper into the solar system at a fraction of the cost. China calls this the cislunar economy, the trade and industry that will one day link Earth to the moon. By 2050, they believe it could generate $10 trillion a year. To them, building a base on the moon isn't just a scientific goal. It's a business move, a strategic investment in the next industrial revolution. But beneath the economics lies something even more powerful: national identity. In 1969, the Apollo landing crowned the United States as the symbol of progress. For China, doing the same in the 21st century would rewrite that legacy. It would prove that their system, their vision, and their discipline can achieve what once defined American greatness. And it's not just about pride, it's about control. The nation that dominates the moon will control access to deep space, dictate the flow of resources, and set the rules of future exploration. In other words, whoever builds first may define who humanity becomes next.
China's approach reflects its philosophy: not a sprint, but a long march. Every mission builds on the last. Every rover, orbiter, and satellite fits into a larger pattern. Learn the terrain, test the systems, and prepare the ground for humans. Meanwhile, in the United States, the tension is growing. NASA's Artemis program is still targeting a crewed landing by 2027, but even insiders admit that delays are stacking up. As one former astronaut put it, China could absolutely beat us back to the moon. And if China's plan works, that gateway won't open under a blue and white flag, but under red and gold. building the machines for mastery. China's plans for the moon aren't just ambitious, they're methodical. Every piece of hardware, test flight, and prototype fits into a grand design that's been quietly unfolding for years. If the last chapter was about why they're doing it, this one is about how they'll pull it off. To conquer the moon, China needs three things: a rocket powerful enough to lift them there, a spacecraft safe enough to carry humans, and a lander precise enough to bring them down gently onto the lunar surface. At the center of it all stands the Long March 10, a heavy-lift rocket still under development, but already shaping China's future in space. Standing nearly 295 feet tall, this three-stage giant will be capable of sending 60,000 pounds of payload into lunar orbit. Its first test flight is scheduled for 2027, and if it succeeds, it'll be the launch vehicle that carries China's first astronauts toward the moon. Its power comes from 14 YF-100K kerosene-fueled engines, each generating around 220,000 pounds of thrust. The design builds on proven Chinese rocket tech, strong, reliable, and now aimed at something far more ambitious. But China isn't just trying to build a massive rocket, they're trying to make it reusable. Each of the Long March 10's booster cores is designed to perform a controlled propulsive landing, similar to SpaceX's Falcon Heavy. But here's the twist. Instead of using landing legs, Chinese engineers want to catch their boosters mid-air using a network of steel cables and tethers. It's a wild idea, but if they can pull it off, it would reduce costs dramatically and keep pace with SpaceX's reusability revolution. The second key piece of the mission is the Mengzhou Crew spacecraft, China's version of NASA's Orion capsule. Weighing around 57,000 pounds, it can carry 3 astronauts, known in China as taikonauts, on a round trip to lunar orbit. China already completed an uncrewed test flight of Mengzhou back in 2020, proving it could handle re-entry speeds of nearly 25,000 miles per hour. The spacecraft is expected to become fully operational by 2027, right on schedule for the first crewed lunar flight. But a crew capsule can only take astronauts to lunar orbit. To reach the surface, they'll rely on China's first human-rated lander, the Lanyu, which translates to embracing the moon. Lanyu is made of 2 sections, a descent stage equipped with landing engines and legs, and an ascent stage that will launch back to orbit. Together, they'll allow 2 astronauts to land, explore, and safely return to the waiting Mengzhou in lunar orbit. In August 2025, China successfully performed a live test of Lanyu's landing and takeoff systems at a test site in northern China. The demonstration proved the lander's engines, guidance system, and stability controls. Essentially, a full rehearsal for what will happen on the moon. Meanwhile, China has also unveiled its next-generation lunar EVA suit, sleek, flexible, and built for motion. During a live demo, an astronaut performed squats and full turns to show off the new mobility system. Alongside it, engineers revealed a foldable 2-seater lunar rover, small enough to fit inside the lander, but capable of covering up to 6 miles on the lunar surface. These are not isolated inventions. They're interconnected pieces of one machine, China's lunar plan. Every rocket, capsule, and rover is a cog in a system designed to work together with precision. And to see how far they've come, we need to look at the missions that started it all. The robotic pioneers that set the stage for everything about to unfold. China's robotic moon missions. Before China sends humans to the moon, it's already been sending machines. And those machines have been quietly rewriting the rules of lunar exploration. These robotic pathfinders are more than just test missions. They're scouts, engineers, and scientists all rolled into one. Each one teaching China how to build, land, and eventually live on the moon. And if you've been wondering how they've advanced so quickly, this is where the story begins.
China's Chang'e program, named after the mythical moon goddess, started in 2007. The early missions were about mapping the lunar surface, but over the past decade, things have escalated fast. The turning point came in 2013, when Chang'e 3 achieved China's first successful soft landing on the moon, something no one had done since the 1970s. It deployed the Yutu rover, which rolled across the lunar soil, marking the start of China's new era in space. But that was just the opening act. In 2019, China made history again with Chang'e 4, the first spacecraft ever to land on the far side of the moon, a region no other country had reached. It's often called the dark side, though it's not literally dark. It's just permanently turned away from Earth. This feat required a relay satellite parked 37,000 miles above the moon to maintain communication, a move that stunned even veteran space agencies. Then came Chang'e 5 in 2020, a robotic mission that not only landed but also collected and returned lunar soil samples to Earth. That made China the third nation in history, after the US and the Soviet Union, to bring back material from the moon. But China didn't stop there. In 2024, it launched Chang'e 6, and this time, it aimed for the impossible, returning samples from the far side of the moon. Landing in the Apollo crater, Chang'e 6 used laser-guided imaging and variable thrust engines to lower itself precisely onto rugged terrain where no one had ever touched down. Over a single week, the lander drilled into the surface, scooped up nearly 5 pounds of lunar rock and soil, and launched a tiny ascent vehicle back into orbit. From there, the samples were transferred to a return capsule bound for Earth. That moment quietly made China the only country to pull off an automated docking and sample transfer in lunar orbit. It wasn't just a mission, it was a rehearsal for a future human return. Next up is Chang'e 7, set for 2026, a far more complex mission targeting the moon's south pole, the most valuable region of all. Why? Because that's where scientists believe vast reserves of frozen water lie hidden in permanently shadowed craters. The lander will deploy a rover and a small hopper drone to explore those dark zones, drilling into the surface and vaporizing samples to test for ice. If that's successful, Chang'e 8, scheduled for 2028, will take the next step, testing construction technologies on the lunar surface. The mission will include a 3D printer capable of turning lunar soil into building blocks. Those blocks will be assembled by a 220-pound robotic arm to form basic structures, China's first human-made building on another world. To most people, these robotic missions seem small, short news stories that fade within days. But to China, they're strategic milestones, each one unlocking a new piece of the puzzle. Navigation, communication, precision landing, and resource extraction. Step by step, these pathfinders are laying the groundwork for something far larger than exploration. They're building the foundation for occupation. Because when China's astronauts finally step onto the moon in 2029, they won't be walking into the unknown. They'll be walking on familiar ground, charted, tested, and prepared by machines that got there first. And from there, the next phase begins, the mission that turns exploration into permanence. The 2029 moon landing. By the end of the 2020s, China's robotic missions will have finished their scouting runs. The data will be mapped, the landing sites confirmed, and the technology ready. What comes next is the most daring step any nation has taken in over 50 years, sending humans to walk on the moon again. The target year, 2029. The objective, to land a Chinese crew on the lunar South Pole and return them safely home. This isn't a test flight. It's a demonstration of capability. A signal to the world that China's space program has matured to the level once held only by the United States. But while NASA's Artemis program continues to face delays, funding battles, and technical challenges, China's timeline remains tight, methodical, and believable. The mission will start with 2 launches from the Wenchang Space Launch Site on Hainan Island. The first Long March 10 rocket will send the Mengzhou crew spacecraft into orbit with 3 astronauts on board. The second rocket will carry the Lanyu lunar lander, which will enter lunar orbit separately. Once both vehicles are in place, they'll perform an automated rendezvous and docking maneuver, linking together 240,000 miles from home. From there, the real mission begins. 2 astronauts will transfer into the Lanyu and begin their descent to the moon's surface. Their crewmate will remain aboard the Mengzhou, monitoring their systems and preparing for their return. The landing site will be near the moon's south pole, an area China has been studying since Chang'e 7's reconnaissance missions. It's one of the most scientifically and economically valuable regions in the solar system, home to permanently shadowed craters that may contain ancient deposits of water ice. The descent will be fully automated but monitored in real time from Earth. Lanyu's precision landing system, guided by onboard sensors and optical cameras, will scan for obstacles and adjust its engines mid-flight. Once the engines cut off and the dust settles, 2 figures will step out into the sunlight. The first humans on the moon since 1972, and the first ever to do so under a different flag. But this won't be a long stay. The first mission will last 6 to 8 hours, a short but essential proof of concept. The astronauts will collect samples, deploy instruments, and test life support systems designed for future bases. They'll also scout potential construction zones for the upcoming International Lunar Research Station, the moon base planned for the next decade. Mobility will come from a compact 2-seater rover, lightweight and foldable, designed to explore up to 6 miles of terrain. It'll allow the astronauts to reach crater rims, examine ice-rich shadows, and test communication systems under extreme conditions. Once their objectives are complete, the crew will board the ascent module and lift off, leaving behind only instruments, footprints, and a small metal emblem marking China's arrival. They'll rendezvous with their orbiting crewmate, transfer their samples, and set a home course. If successful, the 2029 mission will make China only the second nation in history to complete a crewed lunar landing and return. But unlike Apollo, this mission isn't meant to end the story. It's meant to begin one. Because for China, the goal isn't just to touch the moon, it's to build on it. And that next step, the creation of a permanent lunar base, could change the balance of power in space forever. Blueprint for a lunar empire. The first human footsteps will make headlines, but what comes next will make history. China's real goal isn't just to land on the moon, it's to build on it, to turn that silent gray landscape into humanity's next outpost in space. This plan already has a name: the International Lunar Research Station, or ILRS. Announced in 2021, it's designed to become the first permanent, fully functioning scientific base on the moon, built, operated, and maintained largely by China. The vision stretches decades ahead, with milestones carefully mapped through the 2030s and 2040s. Here's how it unfolds. Once the 2029 crewed mission proves that China can land and return astronauts safely, the next phase begins: robotic construction. Between 2031 and 2035, China plans to launch 5 ILRS missions, each one delivering a critical piece of the base. ILRS-1 will establish the command and communications hub, laying down power generation systems, likely solar farms, and setting up long-distance data links back to Earth. ILRS-2 will follow with a science and research platform, where instruments will study lunar geology, cosmic radiation, and solar particle behavior. ILRS-3 will focus on in-situ resource utilization, the key to survival, testing how to extract water, oxygen, and fuel directly from lunar materials instead of hauling everything from Earth. ILRS-4 will expand the base with robotic laboratories and experimental equipment, working to produce the first materials built entirely from lunar soil. Finally, ILRS-5 will establish lunar-based astronomy systems, powerful telescopes aimed at deep space, free from Earth's light pollution. Together, these missions will create the foundation for a semi-autonomous moon base, one that can run with minimal human oversight. The early years will be fully robotic, but as the 2030s unfold, China plans to transition to crewed operations, turning ILRS into a permanent human habitat by the mid-2040s. What makes this plan different from NASA's Artemis base camp is the approach. Artemis envisions a mix of commercial and international partnerships, with countries joining through formal agreements. The ILRS, on the other hand, is being built through direct collaboration, led by China and open to countries that share its vision. Originally, Russia was supposed to be China's main partner, contributing technology and funding. But as Moscow became more isolated by war and sanctions, Beijing quietly took the lead, expanding the ILRS alliance to include Pakistan, Argentina, the United Arab Emirates, and members of the Asia-Pacific Space Cooperation Organization, which includes nations like Thailand, Peru, and Iran. It's becoming a global coalition outside the Western orbit, one that could redefine how space alliances are built. Think about that. An entire economy built off-world. Whoever controls the moon's resources could control the next great leap in civilization. And when those first permanent modules rise from the lunar dust, powered by sunlight and surrounded by robotic rovers, the message will be clear. China isn't following in anyone's footsteps anymore. It's carving its own path, and it leads straight into the future. Allies, rivals, and the global moon rush. By the mid-2030s, the moon won't just be a scientific frontier, it'll be a geopolitical one. And the space race won't just be between rockets, but between alliances. While China pushes forward with its International Lunar Research Station, the United States is leading its own coalition under the Artemis program. What's happening now is less a competition between two countries and more like a split in the future of space. Two visions of how humanity should expand beyond Earth. On one side, you have the Artemis Accords, signed by over 30 nations, including major partners like Japan, Canada, Australia, and the European Union. The U.S. envisions a moon built through commercial innovation and open collaboration, where private companies and allied nations share technology, resources, and data. On the other side stands the ILRS, China's answer to that framework. But instead of forming treaties based on American-style governance, China is forming direct partnerships, inviting nations that often feel excluded from the Western space network. Originally, Russia was meant to be the backbone of this project, but after the war in Ukraine and the economic fallout that followed, Russia's ability to contribute collapsed. That left China not just as the senior partner, but as the driving force. To fill that gap, Beijing began building a new kind of coalition. It reached out to developing nations, emerging economies, and regional allies across Asia, Latin America, and the Middle East. It's not just diplomacy, it's strategy. These partnerships not only give China influence, they give access to launch sites, resources, and political leverage across multiple continents. The result? A divided moon. Two competing frameworks shaping how the next era of exploration will unfold. And it's not just about cooperation, it's about control. NASA officials, including Administrator Bill Nelson, have warned that China's ambitions could extend beyond science. In his testimony before the U.S. Senate, Nelson said, "We are in a space race with China, and we must ensure they don't reach the moon under the pretext of scientific research only to claim it as their own." The Pentagon has echoed similar concerns, seeing the lunar push as part of a broader effort by Beijing to counter U.S. dominance in space. not only through exploration, but through infrastructure, surveillance, and resource rights. Meanwhile, China insists its intentions are peaceful and cooperative. It has openly invited other nations to join the ILRS, calling it a shared platform for all humanity. But behind the rhetoric lies a simple truth. Whoever builds the first sustainable base on the moon will likely define how space law, trade, and defense evolve in the next century. And this rivalry is no longer hypothetical. Both sides are racing toward the lunar South Pole, the same small region believed to hold most of the moon's frozen water. NASA's Artemis 3 mission aims to land astronauts there by 2027, while China's first crewed mission will follow just 2 years later. 2 flags, 2 systems, 1 frozen frontier. This new space race isn't about beating a clock. It's about shaping civilization's next chapter. The nations that build on the moon will set the rules for space beyond it. Mars, asteroids, and even the outer planets. By now, this isn't just a race to reach the moon. It's a race to define what humanity becomes once we leave it. Who will own the moon? The moon has always been a symbol of mystery, beauty, and distance. But now it's becoming something else entirely, a battleground for influence, economy, and control. As both China and the United States race toward their respective moon bases, one question hangs heavier than any other: who will own the future up there? For decades, outer space has been governed by an agreement called the Outer Space Treaty of 1967, signed during the Cold War. It states that no nation can claim sovereignty over celestial bodies, meaning, legally, no one can own the moon. But that treaty was written when space was little more than a dream, long before mining rights, lunar industries, or private corporations came into play. Today, those lines are blurring fast. The U.S. and its Artemis partners interpret the treaty to allow safe zones, areas around bases where operations can be protected for safety reasons. Critics say that's just another way of claiming territory. China, meanwhile, has called for new international frameworks, arguing that lunar resources should be shared by all humanity. But at the same time, it's laying down its own infrastructure at the South Pole. Power systems, comms relays, and resource stations, the same way early nations staked out trade routes on Earth centuries ago. It's not conquest by flag anymore. It's conquest by presence. And presence in space is everything. The first to build, the first to extract, the first to operate continuously, they set the rules by default. That's why the ILRS and Artemis programs matter so much. They're not just engineering projects, they're claims of leadership. But the race to harness those resources isn't just about wealth, it's about survival. Earth's resources are finite. Population and consumption keep rising, and as our planet struggles with climate change, space offers something humans have always craved: a second chance. That's why this new race feels different from the Cold War. It's not about ego or propaganda anymore. It's about who defines the next chapter of civilization. The United States sees it as an extension of democracy and innovation. China sees it as proof of national destiny, a modern Silk Road stretching into the stars. Both sides say they want peace. Both say it's for the advancement of science. But when two global powers chase the same frozen crater, with billions of dollars and national pride on the line, peace may not be enough to keep them from colliding. So maybe the real question isn't who will own the moon, but how will humanity share it? Because what happens up there, the rules we write, the boundaries we draw, the values we choose, will echo across the rest of the solar system. The race for the moon isn't about looking back at history anymore. It's about deciding who writes the next one. Thanks for watching. What do you think humanity's next giant leap should be? Share your thoughts below. And if this story sparked your curiosity, like, subscribe, and stay tuned for more deep space discoveries.